FMCC webinar, Efficient Repair, Renovation, and Sustainability Product Delivery Methods. It will be presented by Peter Cholakis. I'm Joshua Amos, the Council Liaison for the Facility Management Consultants Council. Everyone has been muted for audio quality. Please type your questions into the chat box and we'll go over them during the presentation. Next slide, please, Peter. The FMCC does provide many services to the FM community, such as Ask the Expert, Find a Consultant, Locate a Speaker, and online educational resources. You may find more information at their website, fmcc.ifma.org. Next slide, Peter. We would also like to thank our sponsors, ISS Facility Services and Kane Consulting. And also, before we start the webinar, I would like to just let you know that an email will be going out to all that have registered for the presentation, and a PDF copy of the PowerPoint will be included in that email. And also, please note, when you exit the webinar, there will be a box that comes up to ask you to take the survey. I encourage you to take the post-webinar survey. The board does eagerly look towards those survey results. At this time, I will go ahead and turn it over to Peter.
Thank you very much. And especially thank you for everyone attending the session today. And I look forward to hearing your questions and comments. So feel free to ask any questions at any time throughout today's event, and I'll do my best to answer them for you. So really, to get started, everyone is well aware of the issue with construction productivity, certainly in the U.S. and arguably worldwide. So we're focusing on the U.S. today. However, many of the principles that we discuss, again, are applicable on a broader basis. So again, construction productivity is virtually the only industrial non-farm sector to decline over the past several decades. Every other commercial sector has had productivity increases. So we have to kind of sit back and say, why is that? And that's what we'll be talking about today. But more importantly, opportunities for change. Now, some of us out there have talked about this and seen this particular slide many times and talked about the issue, quite frankly, until we're blue in the face. So what's different today? Well, we kind of have to make a change. We know that the economic landscape has changed. Global competition is certainly heightened. There are environmental issues at stake, i.e. non-renewable resources becoming in shorter and shorter supply. So from a competitive and environmental perspective, there are certain drivers out there. But how are we going to change, and who is responsible for change? I use the word responsible here on purpose, and I don't use the word blame, never have. Who is actually responsible for driving change? Well, it's owners, to be honest. I don't know how many owners we have out here in the audience, but quite simply, owners pay the bills. So in addition to those drivers we just talked about, owners need to take on the responsibility, because as long as a group, they're satisfied with the status quo, there won't be any change. So key issues. How do we bring about change? Well, it's really a matter of education and really understanding. We need to understand the fundamental principles associated with the built environment lifecycle management. Those processes, those practices, the metrics. While we're going to be talking about technology, this is not a technology issue. Very little in this presentation today will be new to folks from a broad perspective. Certainly there will be a lot of new information on a practice or detailed perspective. Overall, with respect to the built environment lifecycle management concept, it really began in the DoD sector here in the U.S., followed by higher education, healthcare, and process-based industries. If you look at folks out there with domain knowledge in lifecycle management, likely they've had a background in any of those sectors. Go to a local higher education facility, it wouldn't be unusual to find the executive VP of real estate or director of facility management to have come from the Air Force or the Army, just as an example. With change, there's a checklist. So it's as simple as getting from A to B, and how do we do that? First and foremost, while I said there's no technology issue, there is a glossary of terms issue. We need a robust ontology. Ontology is kind of a cool word. It is quite simply a glossary, a definition, a set of terms, their associated definitions. However, the key part, it's also their interrelated linkages, how information or those terms or processes, classes, subclasses, superclasses, and those are all ontology type terms, relate to one another. And that's a key point. I ask that you kind of keep that in mind as we go forward. Life cycle cost focus. This is certainly key to the U.S. We have been stuck in a first cost mentality for as long as I've been in the industry. Everyone concerned about today's bottom line, what it costs to erect a facility, for example, as opposed to the life cycle cost of a facility. A primary example would be there were several new buildings, actually hundreds of buildings built throughout the U.S. in the last several years. Excellent facilities, some of them LEED certified. They are not being used today. They're standing dormant. Why? Because there's no budget to run those facilities. So we have to look at life cycle costs from a whole range of perspectives, financial, environmental, and so on. Next point, moving from a linear strategy to a cyclical, multifaceted portfolio management approach. If one looks at the definition of a life cycle, you'll typically think of strategy, design, construct, demolish, or some variant thereof. Well, quite frankly, that type of thinking is dead. We need to look at portfolio strategy, project delivery, and other types of integrated and interrelated life cycle frameworks. Last but not least, trust but measure. This one is key to everything we've talked about so far, but how many owners out there do their own internal estimates, whether it's for buildings they construct, whether it's for renovation, repair, whatever the case may be? Relatively speaking, I would say few. Well, that's kind of silly. When you go out and buy a new car, you research it left and right. You research the costs of each additional option. How many builders do that, owners do that, and do it on an apples-to-apples basis? Again, trust but measure. And that's just one example. Here's a key aspect, obviously central to today's presentation, and this is collaborative construction delivery methods. Integrated project delivery being one example, for new construction primarily, and job order contracting being another example, specifically for renovation, repair, sustainability type projects. Both of these collaborative construction delivery methods have been available and have been proven for decades. They're not new. And I can't tell you the number of conferences I've gone to in the last few years on integrated project delivery, for example, and everyone's saying, oh, well, what is it? And or where are the case studies for it, et cetera, et cetera. Folks, they're out there. This is nothing in integrated project delivery or job order contracting is new, and we're going to be talking about that. So my next point being a central aspect to moving forward is not reinventing the wheel. Nothing here, again, is rocket science. Many, if not most, of the processes, procedures, and technologies are readily available. And as I just said, technology is not the issue. You hear a lot about data interoperability. From a technology perspective, again, that's a non-issue. So let's look at it a little bit at a higher level, and this graphic begins to approach or describe that. So we're looking at various forms of project delivery, the pros and cons of each, sustainability, collaboration and communications, document control, integrated processes such as lean, Lifecycle, another acronym for everyone, TCO, which is total cost of ownership. And again, not a single one of these things is new. They're all well defined, even total cost of ownership. There was a document published about, gosh, probably 7 or 8 years ago that defined total cost of ownership and the associated metrics, business processes, technologies required to implement total cost of ownership. And then, of course, standards. Standards are key. And I'm talking about standards that enable apples to apples comparison, updating of information. And these include many that you're familiar with: master format, uniformat. Some you may not be familiar with, such as COBE and OmniClass. And in terms of metrics, there are hundreds out there. We all know about them, going from facility condition indexes to adequacy indexes to energy consumption indexes, etc. So, what are the factors affecting adoption or change? Change, in many cases, if you go through history, it is not overnight. It's upon you before you know it. And I would suggest that change is currently upon us with respect to the entire AECOO industry. Many of us, however, are not aware and may not be prepared. AECOO meaning, and I apologize for the acronyms, but architecture, engineering, construction, operations, owners. So there's organizational issues, clearly. We need executive leadership and support. Human resource aspects in terms of information, people capable of understanding and implementing these changes. Understanding of risk, that's key. That's key to getting the executive leadership and support, by the way. You've heard this, many of you have heard this many times, I'm sure, that facilities are directly linked to the mission and or success of failure of an organization. It could be financial or mission-oriented. It's up to facility managers and executives to define that risk and define it clearly to an executive and therefore get those financial resources. Market factors. We talked about that. I'm not going to spend much time on it other than we know they're environmental, we know they're economic. Mandates are here and they are coming. They've already occurred in Europe, whereby, just as an example, when real property ownership is transferred, along with it needs to go the history of energy consumption and associated conditions for those buildings. That's going to happen here in the U.S. if it hasn't happened already. And there'll be other regulatory or statutory mandates. Standards, again, we talked about the BIM ontology. Cloud computing. That is not a buzzword. I know that there's a lot of folks out there that say cloud computing, is hype. That couldn't be further from the truth. It is an entirely new way of managing, storing, accessing information. It's a presentation in its own, but for those of you who haven't spent the time, it's critical to look at cloud computing. Education, support, and training, that's really fundamental to this change. I would argue again that our educational system has not kept pace. We are still teaching architecture as design. We are not teaching fundamental life cycle management practices. We are not teaching, in many cases, I know there are certain exceptions, and excellent exceptions, by the way, but we're not teaching students anything about the business world. What really has to happen once they leave? How architects, for example, relate to contractors, AEs, the owners, etc. Of anything we talk about today, this is probably the most fundamental, and I apologize for the busyness, if you will, of the slide, but this is literally the life cycle management framework that is available for all to see. Part of this is an ISO standard, meaning items in green, as well as the blue icons or subheads directly under the green circles. So this is the life cycle of the built environment in terms of A, portfolio management, where one looks at the strategy, basically what do we need, conceptualization of how we need it, how we're going to proceed, where we're going to get funding, et cetera, et cetera. Project delivery is the next fundamental substructure. Project delivery methods drive the success or failure of many projects. Certainly the composition of the team is related, but if you put, again, similar teams together, the project delivery method will have the most impact on the overall success or failure. Traditional design, bid, build should be dead, but unfortunately it is not. It's archaic. It is counterproductive. It pits builders against owners, against architects, against building users from day one. It also precludes information sharing and creates waste. So again, a collaborative project delivery method is key to getting all stakeholders involved at the portfolio management stage and then throughout the process as required. Certainly actors can come and leave the life cycle at any time. Within any life cycle, there are obviously multiple individual processes going on. However, one needs to look at each of these core fundamental life cycle stages. Property management, all aspects of asset operations, maintenance, space issues, utilization, safety, life safety, etc., are all handled here. And then, of course, disposal and or recycling. Associated technologies. Each of these business processes must be supported and enabled by technology. As I said earlier, technology is not the issue. The technologies are out there. The role of the technology is to help support and enable initial low-cost implementation, however, also ongoing, transparent, and consistent implementation of standardized practices, as well as the ability to monitor, check, recheck, and adapt those processes. So what are the key technologies? Number one, CPMS. And again, this is not in order of importance, but just following the life cycle. So capital planning and management systems, an example would be here in the U.S., VFA Inc. There are multiple other ones. So this is a technology where you look at what-if analyses. You look at how much money you currently have in your budget, but more importantly, how you're going to allocate that over time with respect to physical condition and functional condition. There are metrics that can be applied to both at multiple levels. You can link them directly to physical aspects, whether it's individual buildings, building systems, subsystems, etc. And you play these what-if analysis over time. For example, and again, a basic example, but if you're going to invest at a certain rate, you're going to be at a facility condition index of, say, 0.4 as opposed to 0.1 or 2, where you may want to be. So you would adjust that investment accordingly and play with those scenarios. You can also compare your O&M costs to the construction of a new facility and look at that in dollars over time, so to make informed decisions in terms of renovation, repair versus replacement. So again, linking the facility to the functional needs of an organization comes into play at this particular technology/stage. IPD or JOC. We're going to talk more about this, but there are technologies that support implementation of the project delivery methods, again, for the same reason I mentioned, standard terms, ability to share apples-to-apples data. CAFM systems, there's been a lot said about the definition of CAFM systems. Originally, it's space planning and utilization. Obviously, now there are multiple ways to visualize spaces, but in terms of CAFM, I'm treating it as visualization tool regarding, or relative to space planning, I should say. CMMS, this is computerized maintenance management. This is the day-to-day general maintenance. This is not capital planning. Again, companies, organizations can put different thresholds on the difference between the CMMS system and a CPMS system. Typically, it's around $10,000, $20,000, $30,000. What's referred to as a operations and maintenance expense versus a capital expense. So how often you replace a coupling on a pump would be, and where that pump is located, the number of that pump, the number of the coupling, the man hours required, and the crew required to change that coupling, are all in or should be within the CMMS system. Just a key point here, also within that CMMS system should be a standardized cost database. Why do I say that? Because in most cases, CMMS systems depend upon costs, crews, materials, labor developed by the organization. Well, that's great, but that doesn't mean that you're doing it A, correctly, or B, as efficiently as possible. So having a standard cost database that you can refer to and or a peer-based benchmark is, in fact, one way to look at continuous improvement for your various CMMS tasks. Building automation systems. I'm sure everyone knows what those are. This covers the gamut from real-time monitoring of your energy needs to tracking personnel, building users, etc., as well as safety equipment and so on. GIS plays a role throughout all aspects of lifecycle management in terms of physically locating items, people, managing space utilization, multiple aspects that have yet to even be explored. And now with the advent of 3D GIS, i.e. being able to locate items or things on different floors, we'll see a whole new range of capabilities. So we're looking at here a description of the built environment lifecycle, associated technologies, associated competencies required for these various aspects, and their potential impact upon the society, economy, environment, etc. By the way, I'm also on this committee, the NBIMS 3, which is the National BIM Standard Terminology Committee. We have adopted the life cycle as shown moving forward, and as a component of BIM defined as the life cycle management of the built environment supported by digital technology. We will be evolving an associated BIM ontology and so on. So, traditional project delivery versus IPD. Traditional, quote unquote, is design, bid, build, even design build to a certain extent, construction management at risk, and those are just a few, versus integrated project delivery, job order contracting, public-private partnerships, and others with various terms and names. What's the true difference between them? Well, you just look at key aspects: the participants, the process, the risk, the compensation, and the technologies. So traditionally, you're moving from ad hoc, typically hierarchical, and certainly fragmented, to teams, to projects. These teams may form and disband over time. However, the information is retained, and there are incentives to collaborate. We'll talk more about that. Processes. Traditional processes are linear, they're silo-oriented, certainly limited information exchange. In that prior example of CPMS, CMMS, and so on, those technologies don't talk to each other for the most part. That needs to go away. Those processes are not interrelated. That should go away. As opposed to concurrent life cycle shared information processes. Risk, collectively and shared. In integrated project delivery, I'll just give you one example. In the job order contracting world, if the contractor or contractors are awarded projects, they're awarded on a dollar amount over a period of years. Their success and failure, how much work they get to do, is based upon their ability to deliver projects on time, on budget. So there's the incentive to work hand in hand with the owner. The contractor gets a long-term relationship. The owner may not get the lowest price on the street for that particular project. However, they will have insight into their actual budget. There will be far fewer surprises. Arguably, at the end of the day, they're going to spend less money. And we'll talk more about that. Technology, it's moving again from paper-based 2D presentation spreadsheets to object-oriented centralized data sets, cloud computing. Spreadsheets are great, by the way. Don't get me wrong. Spreadsheets I use every single day. I'm sure everyone here on this call opens up a spreadsheet every single day, if not multiple times. I probably spend, I don't even want to share this, but I probably spend at least 2 to 3 hours a day in a spreadsheet at some point. That said, it's good for one purpose. It is good for looking at and organizing information once I get it. There's little value in a collaborative environment. The key reason being there is absolutely no concept of hierarchy in a spreadsheet. You can't combine multiple spreadsheets into one. You can't easily monitor changes within spreadsheets and track them to the original owner. We have to get away from spreadsheets with respect to several business processes and several technologies. We need to look at technology that supports specific business processes, obviously customizable for owners, architects, engineers, etc. So let's take a look at the whole aspect of lean construction. We've got an error on the slide. We've got collaboration levels 3, 3, and 3. It should be basically the least collaborative design, bid, build, enhanced collaboration, design, build, CM at risk, and then true collaboration, IPD, and lean at the very top of the slide. All right, let's drill down now into some details. Job order contracting is a form of integrated project delivery, as I noted earlier, specifically for the numerous projects related to O&M, obviously renovation, minor new construction, other aspects as well, sustainability projects. We all know from an economic perspective, the shift is from new construction to renovation repair. You can look at any financial data set to justify that or prove that. You could probably look at your own individual budgets to prove that. But here's a set of phases associated with JOC in the diagram. Each of these phases involves the owner and contractor, builder, tradesman, AE as required. They are not done individually. They are all shared through a centralized software platform. They are all using the same cost data. They're all using the same data hierarchy. And these steps range from initial project definition to a joint site walk or site visit of the actual job, actually pointing out what needs to be done for that office renovation, conference room renovation, building renovation, etc. Various stages that check and recheck what's happening, and you can track these stages in software, but you can also share information at each of these stages and recall the information of these stages and apply them to future projects and leverage them. So the end result of all of this, again, is a higher level of productivity, shorter procurement times, shorter procurement costs, basically more projects done on time, on budget, and oddly enough, a virtual end to legal disputes. Sure, that would be something that everyone would want to achieve, and significantly reduced number of change orders. So how do I justify those terms? Well, or those statements. JOC has a 25-year plus track record within the DoD. It's now moving out into other sectors, higher education, state, local government, healthcare. It's moving out of the private sector into the public sector. Traditional JOC contract is 5 years long. Some of them are 3 years long. As I noted, this isn't for everyone. From an owner perspective, a contractor's perspective, AE perspective, everyone needs the same mindset, which is, at the end of the day, quite simple. A, I'm going to share information. B, I'm going to be available virtually on demand to support each other. And the recognition that everything is performance-based. And the also recognition of the fact that I'm looking for a job done correctly for a reasonable fee. So it's win-win-win. By the way, not only does the contractor know and have some visualization into their revenue stream over the number of years, providing they're doing a good job, but the owners now have greater cost visibility. And they get quality work on demand. They work with contractors who know their facilities and are typically local. I talked a bit about shorter procurement times. This is an example, literally going from years to months or weeks. There's just one example of time savings and cost savings. This is the McLearney curve, which, again, many of you have seen. Quite frankly, job order contracting and IPD link with number 4, what's called here the preferred design process. Whereas traditional design bid build is the black line, number 3, and design build would be somewhere in between. At the end of the day, clearly, the more information that is front-end loaded, the more likely it is that you can impact cost in a positive manner and obviously impact the project with the least impact to your capital budget. So let's take a quick step back and look at some higher level items. We talked about a bit about project delivery, standardized cost data architectures. RS means is just an example. All we're talking about here from a cost perspective is having a standard data architecture, whether it is uniformat, master format, whether it's functional descriptions, again, a BIM ontology. Comprehensive online real-time document management, not spreadsheets. Electronic visualization, quantity takeoff, 3D visualization. From an owner perspective, this is, again, a detailed slide. The presentation will be available to everyone. There are multiple white papers available describing this process in detail, but this is an owner perspective of a JOC project. So it goes from a programming estimate, which is a budgetary estimate, ranging through proposals to technically evaluated proposals. This is where the owner looks at the contractor's proposal, line item by line item, system by system, electronically. The contractor's budget is in the same format as the owner's internal estimate. The owner pushes a button. All differences are highlighted. That's the technical evaluation. The owner can then put a note on the particular item. Contractor will clearly understand it, and they can much easier, or in a much easier manner, I should say, come to a resolution to that particular difference throughout in the proposal. So these are, again, various steps. There are pre-negotiation strategies, post-negotiation summaries. Far too much information to go in detail, but this is a robust project delivery method proven for over 25 years. So none of this is possible, by the way, without standardized data. I know I've mentioned it multiple times. So we're looking at things like Omniclass. Omniclass is not ready for prime time as we speak. It is growing. I'm on an Omniclass development committee. There are several. Anyone who would like to volunteer or be part of it is welcome. Omniclass includes uniformat and master format, but basically it looks at all aspects of the built environment, both vertical and horizontal, and puts together a classification structure. IFC, similarly, is taking information as I've just described and applying it on a technical level and enabling it to be deployed in a consistent, standardized manner. And then, of course, metrics, which we've talked about. We've talked about a few of them, like Facility Condition Index, System Condition Index, and higher level aspects such as cost per gross or net square feet, utilization rates, etc. So in general, we're looking at win-win situations, best-in-class lifecycle focused processes, technologies, and services. moving away from proprietary vendors, proprietary data formats, to non-proprietary open standards, etc. So technology. Talked a bit about cloud computing. Cloud computing literally enables you as an owner, contractor, or AE, building user, to allow access, instantaneous access to information at a predetermined level, shared access, but also shared ability to edit the associated data. You can roll forward and backward in time. Think of your, whatever it is, Internet Explorer or other type of browser that you use, Chrome, Firefox, etc. That little thing at the top where you can move forward and backwards. That's exactly what cloud computing is. You can measure changes down to 50 milliseconds. You will know exactly who made the change, the date they changed it. Last but not least, the data is never lost. In my opinion, that's the best security there is. I would argue that you're never going to prevent the possibility of someone getting into your system. However, the ability to know exactly what happened and when, have the data never lost, go forward and backward in time, provides the most secure data architecture available. And I really foresee cloud computing as being virtually the sole technology in a relatively short number of years, that is. So we're looking at the ability to manage multiple project types within one program, whether it's IPD, JOC, or other types of projects, standardized data formats, and the ability for owners and contractors to compare estimates on a line item by line item basis, look at variances, etc. Integrating this with visualization tools, all types of automated quantity takeoff, linking those directly to those quantities directly to the cost databases, just as an example. And that brings us to the Q&A session. So I know I've covered a lot of information. I hope that many of you have learned from this new approach. Again, when I say new approach, it is something you have been well aware of, or at least components of it, for a long time. However, implementation, management, having the right data to manage is all key and fundamental to change. And I just wanted to provide a brief description today on one way of achieving that goal. So thank you for your time, and I'd like to open it up to any questions.
Great, thank you. If you do have any questions, please type them into the chat box and I will present them to Peter. We'll give you just a moment to get that in. Is there anything else you'd like to add while we're waiting to see if anyone has any questions? Okay. If you do have any other questions after the presentation, I'm sure Peter would be happy to follow up with you. His contact information is on this slide. And again, I will be sending out a PDF of the slide deck to everyone that is registered, as well as a link to the recording. Okay, and then can you go, oops, our slide went a little weird. The FMCC always does like to just give a spotlight to the other councils that are out there for people to join. You can check those out on IFMA.org. And Peter, I would just like to thank you for presenting.
Thank you very much. I definitely appreciate it.
Great. And everybody, thank you and have a great day. Thank you for attending. Bye-bye.